we have to go to the SCADA software. So I'm opening our SCADA software, and for generating an alarm from the PLC, so for that we'll require a PLC program. So I have created one simple program in which from by pressing the start switch our motor will be operated, and by pressing the stop switch a motor will turn off. So whenever I want to generate a digital alarm, firstly when this motor is operated, so that will give us a notification in our SCADA software that indicates that your motor is operated. This type of alarm I want to just create in my SCADA software. So for creating an digital or analog alarm in SCADA software, first we have to create an alarm server for configuration that alarm in our SCADA software. So that alarm server that can be created in our Explorer window. In the Explorer window you can see our project name. So just right click on that project name, and you can see the add new server option. Go to that option and select tag alarm and event servers, and click on that and write any name. In the description you can write a description of your server, or if you don't write, just left it blank. After that you can see the priorities and history tab. In the priority tab you can write the priority of that particular alarm by providing any number between 1 to 1000. So that will be a range. Like for low priority alarms, range of 1 to 250 is there. So if you write any number among this 1 to 250, so that alarm will be considered as a low priority alarm, which means whenever alarm will be generated in the actual system, so operator can identify which alarm is urgent or which alarm is a normal alarm like regular alarm. So by using this priority we can check which alarm will be considered first. So that will be the range from 1 to 250, that is for low priority. For medium priority 251 to 500 range is there, and for high priority 501 to 750 range is there, and for 751 to 1000 range is for urgent priority alarm, which means that alarm must be considered first for the error. So from this you can change. If you want to change the priority, you can just enable this priority and you can change the numbers. By default numbers are here. And if you want to save the history of this alarm, so that for that you have to select this, and that history will be saved in this path in your computer. After that we have to just click on the OK button. So that server will be created on the Explorer window. As you can see on the left side of in the Explorer, the alarm server has been created. So just we have to expand that server, and after expanding you can see the alarm and event setup option. So just double click on that alarm and event setup, and that alarm window will be opened. So this type of window will be opened whenever you double click on alarm and event setup. So here for creating a new alarm, we have the new option on the top side. So just click on that new option. So you can find these three different options. First one is for configuring the digital alarm. After that you can see the deviation and level alarm. So that will be a type of analog alarm that we'll see on later on. First we create our digital alarm. So for that I am clicking on the digital. So this type of window will be open. First of all you have to write a name for this alarm. So I'm writing motor indication, which means whenever this motor will be operated, it will give me an alarm by the name of motor indication. Here from which tag you want to generate an alarm, so that tag we have to write here in the input tag. So that my tag is here is that is a motor. So that motor, whenever motor will be operated, so it will trigger an alarm to this alarm properties. After that, which condition this alarm will be triggered. So right now the condition is input not equal to 0. This sign indicates not equal. And the second condition is like input is equal to 0. So I want to operate an alarm when my output is on one condition. That's why I'm selecting not equal to 0. After that you can see the severity. So severity is our priority number. You can write any number from 1 to 1000 as per the priority. Just for example, I want to set a low priority for this motor indication alarm. So I can write from 1 to 250 number. So just I am writing a 1 number. After that we have to write a message, which message you want to show whenever this alarm will be generated. So I am writing a message that motor is operated. So this message will be displayed whenever this alarm is generated. After that, just we have to click on the OK button. So this alarm will be saved on the right side, and after that we have to just close this window. And you can add multiple alarms of digital alarm by this process. After creating an alarm, just close this window and save these changes. Now for checking that particular alarms in this SCADA display, we have to take one alarm display. So that will be taken from the objects in the menu bar. You can see in the object alarm and event option. In the alarm and event option, you can see the summary option. So select summary and draw that alarm summary window by just a normal cursor. And this is the some properties of this alarm window, which toolbar you want to show and which colors you want to see in this display. So by default we will use this by default configuration, and if you want to change, you can change the configuration. There are different tabs are available. So directly I'm just click on the OK button. Now for checking this operation, I am connecting this SCADA display to the test display. Okay, so now we will check our first condition of output. Right now output of a motor is in off condition. Now I am starting that output by pressing a start switch from the SCADA. So that you can see here motor is operated, and when the motor is operated, you can see the alarm is generated in the alarm window. So you can see the details of that particular alarm in this alarm window. So first of all, it will showing your date and time. After that the name of that alarm, that is a motor indication, and the condition operated, that will be a trip, which means that is showing that output is operated, and the message, that is a motor is operated, it is indicating that we have already configured when we are configuring this alarm. And if you select that particular alarm, so you can see the priority, you can see alarm date and time, you can see the severity number, you can see the current value, which value of that particular alarm is there. And you can see the red bell icon on the left side of this alarm, which means that alarm is right now operated, which means the condition of that alarm is satisfied in this right now. If I stop the output, I will show you in our programming software. Right now motor is turned off, so the condition of is in the wrong condition, which means right now the alarm is motor is not operated, so alarm will not generate. So as you can see here on the left side of the alarm, this bell icon, it's turned into the blue color, and whenever that alarm is in on state, at that time bell icon will be turned in the red color. So from that you can uh, differentiate which alarm is live now and which alarm is generated in the past. So by using this we can check the alarm condition. Now we'll create an analog alarm. So for that we have two type of analog alarm, as we have seen in our alarm and event setup. The another alarm is deviation alarm and level based alarm. So for that we have to change some our in the programming, because right now the programming is there for just operating a digital output. So for that I'm changing the program. Just for checking the alarm, I am taking a simple move instruction and moving one value to another integer, just for checking our alarm operation, how analog alarm will be generated. So for that I have taken two integers from the source. I have taken integer 0, and that value will be moved to the integer 1. So we can write any analog values in this integer 0 and integer 1. So from that we can easily check our analog alarm. So yes, first we create our tag for integer 0 from our tag window. because integer 0 we will use for generating an analog alarm. So for that I am opening the tag window, and I think yes, integer 0, that tag has been already created, so we'll use this int tag for creation of our or triggering our analog alarms. So we'll use directly integer tag, and again I'm opening alarm and event setup for configuring an analog alarm. Okay, now I am again clicking on the new alarm, and first we check the level alarm, after that we'll check the deviation alarm. So in the level alarm, so this will be level based alarm. So whenever your level is high or low, this alarm can be generated. Just for example, in a tank, if we have a analog level sensor, so according to the signal from the sensor of the 0 to 100%, we can generate this level based alarm. For that I am writing a name of this level based alarm of this alarm. After that, input tag is our integer tag, and we have four conditions. First two conditions are like low and high limit, low limit and high limit. So whenever your value of the low limit that will be exceeded, which means value is lower than your set points, at that time this low and low type of alarm will be generated. And whenever your value of this integer tag will be higher than the set point, at that time this high and high type of alarm will be generated. So here high and low alarm is indicating for high level and low level. High and low limit are used for indicating extremely high condition or extremely low condition. So first we'll check this high and low type of alarm. So just for example, if my value is of this integer is less than 20, so at this time this alarm will be generated, low type of alarm. And whenever value of this integer address will be greater than 80, so at this time this integer high limit alarm will be generated. And severity, just for example I am writing here 300 severity for low priority, so for low limit alarm, and 600 priority for creating a high level alarm. After that, for writing a message of high and low limit of alarm, we have to go to the message tab, and you can write the message. I am writing a limit high exceeded. So this type of alarm I am and for the low limit exceeded. So we'll change this also. High limit exceeded and low limit exceeded. So this type of alarm message I have created, and after that just click on the OK button. So our level based alarm has been generated. So first we'll check this level based alarm, after that we'll go for the deviation based alarm. So this level based alarm is an analog alarm. Whenever our values of that analog input or any analog value will be changed and our condition is satisfied, so for that time our alarm will be generated. And for changing the values of analog our address, right now I am taking the numeric input for that particular our tag, integer tag. In the connection we have to write integer and just click on the OK button. So that value of integer will be right on this box. Now we'll check this alarm. So firstly our integer value is 0 as per our program. Source integer n7:0 value is 0. So right now one alarm is generated, as you can see here. Level based alarm is generated. Low limit exceeded it will be showing, because right now the value of our input tag is 0 and our set point is less than 20. So if you select this alarm, you can see here current value is 0 and limit value exceeded with that will be 20, where our limit is 20 and right now the value is 0. That's why this low type alarm will be generated, and the alarm name level based alarm, that is indicating. Now if I increase the value of this alarm, just for example I am writing the value 30. So at this time this alarm is turned off, which means that is not live now. We will check if this value is updated or not. Yes, I am writing the value again because it's not updated. Yes, right now the value is updated in our PLC. So as you can see here, both the alarms are not live right now. So that will be our past generated alarm. So right now value is not exceeding our low limit or high limit. So right now the no alarm is generated. As you can see here, both the alarms is having blue color symbol. So that alarm is not live right now. Now if the value is exceeded above the 80 value, so again our high limit alarm will be generated. Right now I'm writing the 85 value. So after writing 85 value, so it will create an alarm of an level based alarm of high limit exceeded. So that alarm is generated, and you can see here the color of that alarm is the red color because this is a high priority alarm. So when you just select that alarm, you can see the priority, that is a high, and the current value is 85. Limit for this alarm is 80. So like this we can generate this alarm whenever our value of input is high or low according to the set point. So this is configuration of level based alarm. After that we have and deviation based alarm. So in the deviation based alarm, we can configure a set point, and if our value of input is not nearby the set point, so at that time deviation based alarm will be generated, which means if you have a set point of 50 just for example, and our input value from the sensor is right now 40, so that will be a very much difference. So the if the difference is higher than our set points or set point limits, so at that time a value is deviated, so this type of alarm will be generated in the deviation based alarm. So I am selecting the deviation based alarm and writing the name of deviation alarm. After that input tag is our integer tag, and after creating a input tag which is our target value. So set point is like, just for example I am writing the set point 50 and I'm writing the priority of this alarm, that will be just check what high priority alarm will set. For that I am writing the value of 800. Now condition will check after what is the deviation value, which means in any process there will be a minor error is there, like in the set point of 50 and the actual in the actual process the process is like 50.5, 49.5, so minor error is there. So which is the normal minor deviation error you can accept it, that is acceptable value. So right now I'm writing the acceptable value is 5, which means in the target value if the value is plus or minus 5, so that will be acceptable, but the value is increased from this plus or minus 5, which means above the 55 value and below the 45 value, I want to generate an alarm that indicates that our input value is not nearby the set point. So we can set the condition, which means our input value is less than our target minus deviation value, which means target value is 50, deviation is 5, which means 50 minus 45. So if this condition satisfied, at this time deviation based alarm will be generated. So we are selecting this condition in which our if our input value is less than our deviation value, which means 45, or greater than the deviation value, which means 55. So if the value is less than 45, so at that time also this deviation based alarm will be generated, and if the value of our input is greater than this our target plus deviation, which means greater than 55, so at that time also this alarm will be generated. So we are selecting this both condition, and I'm writing the message that indicates that uh, deviation value exceeded. This message I want to show whenever this alarm will be generated. So we have created our alarm, and just after that we have to click on OK. And for checking this deviation based alarm, I am deleting this level based alarm and motor digital based alarm, so we can easily understand the deviation based alarm. After that I am saving the changes and connecting this display to the test display. So now our value is 85, so that will be higher than our set points, because our set point is 50 and the deviation acceptable is a plus or minus 5, so it will be exceeded the deviation. So right now the alarm is generated, as you can see here, as the priority is urgent priority. So urgent priority alarm will be indicated like this red color, and it will be blinking on and off. And when you check that alarm, you can see the alarm date and time. After that, the alarm name is a deviation based alarm, and condition is high deviation, which means deviation value exceeded on the higher set point, and the message is displayed deviation value exceeded. And when you select that alarm, you can see here urgent priority is here, and current value is 85, limit value is 55. And if I am writing the value of 50, so that will be in our limit. So this alarm will be is not live now, so it will just stop blinking and it will be turned into the green, because that alarm is generated in the past. So and right now the value is in normal condition, so that alarm is not indicating. Now if the value is exceeded below the set point like 40, on the low limit side we have 45 limits. So whenever that limit exceeded, because from 45 to 55 that limit is acceptable for the process. If the value is less than 45, so again the alarm is generated. As you can see here, the alarm is blinking, and right now the condition is deviation low alarm, which means our low set point is exceeded. And you can see here the priority is urgent, value exceeded, current value is 40, and the limit value exceeded, that will be a 45. So like this we can create the deviation based alarm, as well as any alarm we want to create, like analog alarm and digital alarm. So configuration of that alarm is like this, and we can create alarm in our SCADA display. And further SCADA programming and development we'll see in our next video.